Bismillah Rahman Rahim. Nice. Come out with the copies and concentrate. Just have a small class, but understand the concept. And in continuity, it's very important that we learn something in continuity of previous what we have learned. The previous chapter flows into the next chapter, right? It's not disjoint. Whatever we are reading, it's not like we can take a syllabus and do this question, for example. It has to be in continuity with what we have done so far, right? So what we have done so far is that we were trying to have an automata, right? An automaton which accepting some language, and the language we were talking about so far was the regular language. And for any, if we have a regular language, for example, it is generated by regular grammar. So we have a regular grammar which generates regular language, right? So that means whenever we say grammar, there are rules. It is a set of rules, right? So it is a set of rules which generate this regular language. And the automaton we were having which accept these languages, the regular language accepted is the finite automata. In finite automata, we could have the deterministic finite automata, we could have the non-deterministic finite automata, or we could have the NFA with epsilon modes, right? So we could have all these things, and it was accepted by the finite automata. Now we move forward. Now we move what? Forward. Because there is a lot of languages which cannot be accepted by, there is no way we can have the automaton which accept that, the finite automata, right? There is some language where there is no finite automata. We will understand with the examples that which can be accepted by some finite automata. So that means we need to upgrade our regular language. We need to move forward. Even though the regular languages will be there, it will be the subset of that. Okay? Regular language will not be, we are gaining on regular languages moving forward. Where regular language is the subset of that, and we add on few more things. Okay? So that we can accommodate other things which was not accepted by finite automata. The finite automata was not accepting many things. Now we do something, we add up more grammar rules. So we created new grammar. So we created what? That is why if we see the Noam Chomsky's hierarchy, we saw there is the type third grammar is here, which is your regular grammar, which is the subset of the type 2, which we are discussing today, which is the subset of the T1, which is the subset of the T0, right? What is T0 grammar? Which one is it? Unrestricted. What is the T1? Context. What is T2? So what is T3? So regular grammar is this guy which we are reading in the unit first. Okay, we saw the DFA, the NFAs, and etc. etc. They are all accepting the regular language which is generated by the regular grammar. But now we want to upgrade our system. So I could say that T3 is also T2 now. All T3s is CFG, right? But all CFG is not T3 because it's more than this, right? All T2, T3 is T1 because a subset of it. So you understand? So we are moving up, we are moving outwards. So we are trying to have something more. And this was done by 1950s around Noam Chomsky, who tried to create a grammar to represent the natural language. To represent what? To represent the natural language. Please close the door, Ikra. To represent the natural language. What is natural language all about? It's a recursive implement. If I say what is natural language, I will say, to me, for example, I will say it's a recursive implementation of some grammar tools, like, for example, what we call as a parsing. The parts of speech which you say normally, up to the school level, we say parts of speech. What is that? noun, verb, adverb, adjective, and your grammar is actually the recursive application of these parts of speech. That is what the language is all about, right? If you have to do natural language processing, NLP, right? What will you do? You want to see firstly कि noun के बगैर जो चीजें हैं ना क्या वो डिक्शनरी में है कि नहीं, are they in a dictionary, number one. Number two, you have to see is it following the grammar rule or not. Like I say, Hivashi goes to dinner with family. Yes, Hibashi eats dinner with, or if I say Hibashi eats family with dinner, so it will change the whole problem scenario, right? So we have to see grammatically is it correct or not. Now natural language processing is a huge thing, but now this can be used for our programming language, for compiler design. Because what is compiler doing? What's compiler doing? What do you think compiler is doing? It has to see the grammar of that particular language. So that same, for example, I say, for example, we have the Rida comes college regularly. I am saying Rida comes college regularly, right? She comes all the time. At 10 o'clock she is here, right? Isn't it? So if I have to see first the grammar, I will see it should be either the noun phrase or it will be the verb phrase. Now noun phrase can have adjective in it. It can have the noun itself, right? The verb phrase can have the preposition. It can have the adverb. It can have the verb. It can even have the noun. That's why I say it's recursive. It's what? If I parse it, this is what's called a parsing. What is the Rida? It is a noun. What is comes? It's verb. It's doing some job. What is college? Again a noun. What is regularly? Adverb. Okay, it's an adverb. So if I say grammatically look at it, if it is correct or not, I have to see if my sentence has this noun phrase. Phrase means combination of things, not a single thing, right? It could have adjective, it could have prepositions also. For example, I say Rida goes to school. Now with the verb there is also a preposition phase. On this side the subject and object. The subject side we have the noun phrase in the subject phase, then we say we firstly divide the sentence into subject and object, right? Or predicate. Okay? And then we see the subject is a noun, or it could be adjective. I say he goes to, she goes to, or I say Rida goes to, I put up a noun or adjective, and then on this side we will have the verb, and with that we have two preposition. We have school, for example, that is what? Again, that is the noun. So in the verb phrase we could have the preposition, we could have adverb, we can have verb, we can have noun. So we have to see. So in totality, if I want to check whether my language is correct or not, I have to check the grammar. The grammar has rules. Grammar has what? Same applies to your programming language. What will the compiler doing before giving you the output is correct? Before executing it? There is a parser. There is what? Like we parser this language, there is a parser. What? We checks your language, I mean programming language, for the grammar. And there could be those syntactic errors and all. Right? You getting my point? So this thing, which the grammar which resembles our natural language is called the context-free grammar. What is called? This is actually C, yeah? Not G. Context-free grammar. Let me erase this. It is context-free grammar. And the language it generates is context-free language. And the automata which accepts it is called as the push-down automata, which we have to discuss in this session. Right? Push-down automata. So we upgraded ourselves from the regular grammar, having regular languages, generating regular languages, added accepted by the final automata. Now we are upgrading to context-free grammar, which is generating context-free language, which is in this context-free language and all, we have some kind of a variables like noun. We start with the noun. Now from the noun we derive something. We derive rida. Now rida can't be further, derived. It's a terminal. It's what? You get my point? So we have some initial variables like noun, verb, preposition, whatever that is. Okay. Then it moves on to some to terminals. So if we talk about the grammar here, we have the set of variables. Because I told you grammar is made of 4 tuples last time. Okay. It will have a set of variables. Set of what? These variables will be finite and non-empty. So it will be non-empty and finite set of symbols, I could say. Okay? Then when you evaluate the variable, okay, you get the terminal. You get what? The terminals I get the variables, which is same as your input, the sigma, okay, the symbols alphabet now we have, because maybe my alphabet is 0 and 1, so that means it will be evaluated to the non-terminals will be evaluated to what? 0 and 1, and so it is non-empty finite set of symbols. Again, it will be non-empty finite set of symbols shown by small letters, and this one is shown by capital letters. इसमें A, B ऐसे वगैरह आएगा कुछ, ठीक है? इसमें जो है shown with small letters like A, B, C, ठीक है? ये तकरीबन सेम ही है जो हमारा सिग्मा था ना, ठीक है? और ये जो नॉन एम्प्टी सेट ऑफ जो सिंबल्स आपके हैं ना V, इसमें एक सिंबल होगा जहां से शुरू होगा. जैसे ना हमारा था Q नॉट, वहां पे जो 5 टपल हमारे पास था उसमें Q नॉट से शुरू करते थे स्टेट से. यहां पे जहां से स्टार्ट करेंगे ना हम, दैट इज कॉल्ड S. दैट विल बी द स्टार्ट वेरिएबल. दैट विल बी व्हाट? एंड स्टार्ट वेरिएबल विल बिलोंग टू व्हाट? Such that S belongs to V. It has to be from this V, which is what? Non-terminal. Non-empty finite set of symbols called non-terminals, variables. And this is again the non-empty finite set of symbols shown by the small letters called the terminals. Called what? Called terminals. Terminals क्यों बोलेंगे? Why we call it terminals and why we call it variables? Variable शुरू होता है, जैसे मैंने कहा noun. Noun के बाद मैंने रिदा निकाला, so रिदा becomes terminal. Rida becomes what? You can't further convert rida into something. Rida is rida now. But if I say noun could have been the Fozia, it could have been Lily, it could have been Silly, whatever name. It could have been anything. But once you have converted it, it is no more being, But there will be another rule. Now, why is the grammar rule coming up? Now there is a grammar rule which tells us how this variable will convert into that terminal. Right? जो आपका पीछे जो ग्रामर था और इसमें ग्रामर में क्या फर्क है? यही फर्क है. How you convert your variable into terminal. भाई यार क्या करना है? तुम लोग क्यों कंफ्यूज हो गए? तो सिंपल है ना. आपके पास वेरिएबल, मैंने कहा ना नाउन है, वेरिएबल है. Why is variable? Why is we call it variable? Because it can take any value. Right? Name, it can be Junaid, it can be Juni, it could be Hibashi. Okay? You getting my point? But once it is converted to Junaid, is Junaid a variable? It is terminal. We are done with it. But should it be converted into Junaid or should it be converted to this? Should it be converted to this verb or whatever? It depends upon the production rules. It depends upon the what? The rules we have for the CFG is called the production rules. We call them as what? So that is the P. P is the production rule. P is what? How you convert a variable into the terminal is the production rule. Is the production. You may have one production rule or multiple production rules, but you have to convert using only these rules. Getting the point? If we take a simple example, you got this? So we have the 4 tuples. So in CFG, we have 4 guys. First one is the V. What is V saying? Variables. Okay, we call them as a non-terminals. What about T? Shown by capital letters. What about T? Shown by small letters. Also called as terminals. Terminals cannot be further, converted into something. Right? Once it is variables can be converted to terminals, we are done with then we are done. But if there is a variable, till then, see, when will our final string come? When will our final string come? When there will be no variables. जब हमने सारे variables को खत्म किया ना, तो हमारा मिल गया. You getting? If we wanna, for example, give an example, and what is the P? What is the S? Somebody has to start, na? And it has to start from the variable. It has to start from what? What about P? Production rules. So that means we will have left hand side going to right hand side kind of a thing, right? So in CFG we will have, say for example, S using some production rules going to some T. Right? But this side, if I say it can be, again ST. What does that mean? ST, it can be ST. So if I say alpha, this is alpha, it can go to either alpha, okay? Alpha can go to beta, or it can go to the combination of the two. What does that mean? Is, for example, we have S, it goes to 0, S0. 0S. So I am converting S into 0S0. S is still there. Okay? You getting my point? So this can be the combination of terminals or variables. It can be terminals only. Okay? It can be the combination of terminals and variables. From the left hand side, it has to be some variable, which we have a start variable which got into this thing. We will understand it with an example. For example, we have to generate the palindrome. Let's see if you want to accept our automaton to accept the palindrome. Accept what? So let us try to work on the palindrome, right? You can go to the next page. Okay? We have sigma as 0 and 1. We can take only 0 and 1. Okay? Start symbol is S. Start symbol is what? Okay? Now the terminals also will be from 0 and 1, right? Because terminal or T or sigma is our what? 0 and 1. These are the terminals. That means my variables can get converted into 0 1s only. Okay? Now start symbol is S. What is required now? We got start symbol, we got this. We have now 4 things. What are the 4 things? Production rules. Other than what else we have? We have variables. We have variable is maybe, we have the variables S. Only S. Variable is only, and my start symbol is S itself, which starts from the S. So I got 3 things. What is left out? Production rules. Production rule P, okay? पहला rule जो मेरा है वो है कि S goes to, with the arrow means tends to 0 S0. Okay? Second rule है मेरा है S tends to 1 S1. S is the same variable, huh? Because I can't have variable other than S. And another third rule I have is S tends to either 0 or 1 or empty, epsilon. Is sigma shown like this? How is sigma shown? Huh? What am I? I'm confused. Like this, huh? Okay. This is the epsilon. This is what? Okay. 0. So I can have these production rules. Now, if I want to generate, I will see whether the palindrome is generated or not using this language. I have to start from. I cannot start from 0. I have to start from some variable. What is? How many variables I have here? That is. So I have to start from S. S can go to what? Maybe I take this rule. You can take any rule, your choice. No matter which rule you choose, there should be palindrome. What is meaning of palindrome? इधर से आएंगे इधर से पढ़ेंगे जैसे मैडम है हमारे पास. You read it M-A-D-A-M or you read this way M-A-D-A-M. The palindrome, you know that already. Now S, I will use, this is what is this? 0S, 0, right? Are we done? No, because there is still, okay? My 0 and this 0 is still there. I can convert S into this or this or this. Maybe I use same again. I can use recursively what I want. I can use this one again. So S convert to, okay, am I done? No. I can convert this S. Use any rule. Maybe this time this one. Or you can use 100 times this, 10 times this. It doesn't matter. I have to see, I will check the palindrome when I am done. When will I be done? When there is no S. When there is no variable. We have only terminals left. Does it make sense? Okay. Now convert this S into 1S1. This is 0, 0. This is 1S1, 0, 0. Are we done, baby? No, we are not. Why? It's enough playing with this. We can plug in anything. We can plug 0, we can plug 1, or we can plug empty. Okay? If I plug empty, it is gone. Then we have to erase this. Gona khatam. If I plug 0, 0 can come in place of this. If I plug 1, 1 can come in place of this. What else you want to choose? Tell me. 1, okay, I will put up 1. So on this side is 0, 1, 1. This is, if this side this is 0, 1, 1. Isn't it same? You go this way or this way, it's palindrome. Can you check it's palindrome or not? It is. Even though here you have chosen 0. 0010, 0010. The same thing. Getting my point? So again, maybe you have chosen epsilon. That means this is gone. Then it will be 001 100. You go this way 001100 001100. So we are done. We are what? Now this thing cannot be done by the regular language. This thing could not have been done by what? But this thing can be done by the context flow, context free grammar, not flow. So in short, let's come to the end of this lecture. Then we move on with the examples of CFL and we move on to the push down automata then, right? To generate the automata which can accept these languages. Now tell me, if we have the Noam Chomsky, tell me the hierarchy of that. Completely. I want complete pages. So I have the big, this one, huh? This is my type 1. This is my, and this is my. About 0, 1, 2 and 3. Type 3 is रेगुलर ग्रामर जो होता है वो कौन सी लैंग्वेज करेगा? ऑटोमेटा इज T2 is context free language. What is the automata? What about T1? कॉपी से मत देखो, जबानी बताओ, एक एक बताओ. हाँ आप बताओ. दानिल. Context sensitive grammar. Languages. Automata, what do you have? LBA. Linear bounded automata. Yes. Munazza. T0. Unrestricted. I told you don't come into the class if you don't have this knowledge. Huh? What about the grammar? क्या बता रही हो यार, गोटा बता रही हो. Recursively innumerable. Recursively innumerable. Okay. Last Sadia. What is the automata which accepts it? Turing machine. MashaAllah. We are done. Nice. This can come in an exam. This Neon-Chomsky hierarchy. It comes in a short question, right? और context free grammar पे तो बहुत सवाल आते हैं. ठीक है? Okay. See ya.